Welcome. I am Soumya, Assistant Professor, Electrical Department, Vedavyasa Institute of Technology. Today I am going to talk about the topic hydroelectric. The main component of hydroelectric power plant is a hydro turbines. The selection of the turbine depends upon site characteristics, head and flow available, desired running speed of the generator. The main categories of hydroelectric turbines are impulse turbine and a reaction turbine. These are the So first one is a reaction turbine. Runner of a reaction turbine is completely submerged in water and is enclosed in a pressure casing. Pressure differences across their surface imposes lift forces cause the runner to turn or rotate. Next one is the impulse turbine. It never immersed in water but operates in air, driven by a jet of water striking its blades. The nozzle of the penstock converts the head of the water into high-speed jet that hits the turbine runner blades. Utilizes the change of momentum of the water and converting this as force on the blades, enabling it to rotate. They are only suitable for relatively higher heads. Next one is the advantages of impulse turbine. The main advantages of impulse turbines are usually cheaper than reaction turbines, no need for a pressure casing, simple design, easier to fabricate and maintain, greater tolerance towards sand and other particles in the water, better part flow efficiencies. Next one is impulse and reaction turbines are high head, medium head and low head. The categories of high head, medium head and low head is shown in figure. Pelton turbine. It consists of a set of specially shaped buckets mounted on a periphery of a circular disc, turned by forced jets of water which are discharged from one or more nozzles and imbue on the buckets. The resulting impulse spins the turbine runner, imparting energy to the turbine shaft. The buckets are split into two halves, so the central area does not act as a dead spot incapable of deflecting water away from oncoming. This is a schematic diagram of a Pelton wheel turbine. Next one is a turgo. Turgo has a certain advantages over Francis and Pelton designs. The runner is less expensive to make a Pelton wheel. It does not need an airtight housing like a Francis turbine. It has higher specific speeds. It can handle greater quantum of flows than a Pelton wheel of the similar diameter. Preferred for SHP where low cost is very important. Water does not change pressure but changes direction as it moves through the turbine blade. This is a schematic diagram of a. Next one is a Francis turbine. Radial flow reaction turbines, fixed runner blades and adjustable guide vanes are there, used for medium heads. This is the main feature of a Francis turbine is used for a medium heads. The runner is composed of buckets formed of complex curves, usually includes a cast iron or a steel fabricated scroll casing. To distribute the water around the entire perimeter of the runner and to guide and regulate the flow of water, several series of vanes are required. Water changes pressure as it moves through the turbine, transferring its energy. Such turbines are suitable for sites such as dams where they are located between the high pressure water source and a low pressure water exit. This is a schematic diagram of a Francis turbine. Next one is a Kaplan turbine. These are axial flow reaction turbines. It has adjustable blades and the main advantage ability to work in low head sites. Widely used in high flow low head power production. Working fluid changes pressure as it moves through the turbine and gives its energy. The inlet is a scroll shaped tube that wraps around the turbine's wicket gate. Water is directed tangentially through the wicket gate and spiral on the propeller shaped runner causing it to spin. Efficiencies achieved for Kaplan turbine are over 90%, mainly due to the variable geometry of the wicket gate and turbine blades. This efficiency, however, may be lower for very low head applications. They are very expensive to design, manufacture and install but operate for decades. The turbine selection criteria are the net head. Main factor is a net head range of discharges through the turbine, rotational speed, and the cavitation problems and the cost. These are the turbine selection criteria. So mainly hydroelectric power plant has three turbines. Impulse turbine and reaction turbine. Impulse turbine reaction again classified into Francis, Kaplan and Pelton. Turbine selection criteria is there. So I am going to wind up this topic. So thank you.